Hi, this video we will be looking at calculating the entropy change for a rigid tank. So this problem, they said this is a rigid tank, and the inside there are 5 kilograms of R134. And initially the temperature is at 20 degrees Celsius. And pressure is 140 kilopascal. And then the refrigerant is cooled down and while being stirred until the pressure drops to 100 kilopascal. So P2 is 100 kilopascal. And it's being stirred, so there's a shaft work added to it. And this work, was not told. And they also said there will be a heat leaking out. There's a Q out. Okay. So there's a work shaft work, and there is a heat transfer out. Then we need to find the entropy change, which is the topic for this video. Find delta S. And how do we solve it? Okay, so delta S is going to be equal to final entropy minus initial entropy. That's where we're going, right? So if we could find S1 and then S2, then we find the difference between them. So that's our roadmap. So S1, we know it is those two properties, pressure and temperature. Then we need to go to correct the table. This substance is R134. So we're gonna look at R134 and see what we can have. Okay. Maybe it's better to do this. So R134 the pressure is 140. So we're at table A12 and it's 140 kilopascal, and we find out the saturated temperature is negative 18.77, right? Okay. So the T saturated temperature at 140 kilopascal, it is, oh, I just forgot. Let's do that. It's negative 18.77 degrees Celsius. And our temperature here is 20. So T1 equal to 20 is way greater than the saturated temperature. That means this is superheated vapor. If it is superheated vapor, we're going to go to the right table, table A13, and our goal is trying to find our entropy. So at this 140 kilopascal, that is 0.14 megapascal, and temperature is 20. So look across and look down. We're gonna get our S value here is 1.0624, right? Okay, so that's kind of our K value and kilojoule per kilogram per Kelvin. Now let's look at, we need to find S2, but for stage 2, we only know one property, which is pressure. What would be our necessary second property? Yes, because this is rigid tank. If it's rigid tank, we know V1 is equal to V2. So we need to come back to the same table to find our V1. So V1 is 0.16544 meter cube per kilogram. Okay, so now we know two properties for state 2. V2 is equal to V1 due to its rigid tank, so specific volume stay the same. And we also know its second property, the pressure, which is given as 100 kilopascal. Okay. Then which table then? We're going to go to the pressure table, A12. At table A12, let's look at 100 kilopascal. How is this V2 compared to VF and VG? Well, we realize it's right in between them, right? So our V is in between VF and VG, and we know it's going to be a saturated mixture. If it's a saturated mixture, in order to find S, we needed to know the quality. So we need to find the quality first. And quality, since we know specific volume, that's how we go for it. So it's V minus VF over VFG. Our V is 0.16544. That's our V value. And our VF value, it's right here in the table, minus 0.0007259. And our VFG will be VG minus VF. Okay, so we will be able to calculate our quality. Here, it's going to be about 0.859. So knowing the quality, we can find our entropy now as state 2. So it will be SF at plus XF SFG. At state 2, our pressure is 100 kilopascal. So look at the same row in the same table. We can go to SF value. That is 0.07188 plus quality 0.859, then times SFG 0.87995. That would give us our answer for this. That's going to be 0.859 about. Okay, and I just want you to be aware, sometimes the table you've been using have slight different number than mine. You know, they are modifying those numbers, updated those numbers to be more precise. So it could be a little slight difference. Hopefully that don't bother you, okay? All right, so that's our S, and the unit, oh, I'm sorry, that's not our S value. I got it wrong. Our S value is 0.8278. And the unit is kilojoule per kilogram per Kelvin. Okay, so knowing S2 and S1, we can find our delta S, right? Going those back original thought. So that's going to be our last step. Delta S is S2 minus S1, and 0.8278 minus our S1, which is 1.0624. And this problem have given us the mass, so they are implying to find the actual entropy instead of specific entropy. So in other words, we can come back to add that times mass. So our mass is 5 kilogram. Then we will get our answer in negative value, 1.173. The unit will be kilojoule per kilogram. Okay. So this negative value only tells us during this process, the entropy decrease, right? Okay. That's all. I'll see you at the next one. And we will looking at the entropy change in a constant pressure situation. See you then.